All right, so we know that if a function is one-to-one and has an inverse, well, how do we find that inverse? Well, it's kind of a standard process, which has two easy steps and one hard step. So if we're given f as a function of some variable, maybe it's a function of x or some other letter, you can just replace that letter with y, and then write f of y and set that equal to x. Okay, so all you're doing is just if writing f as a function of y. Then the hard part is we solve for y, and when we say solve for y, we solve for it in terms of x. Okay, you're not going to solve y and get y equals 5. You're going to solve y and get maybe something like 3x plus 1, something like that. And then when you have that x part now becomes f inverse of x. So as soon as you solve this and you get y equals some expression, that expression is f inverse. So the first and third steps are the easy ones, and the middle step is where you do all the work. So to show how this would work, let's say we wanted to find the inverse of this linear function, 5x plus 8, right? So we write x equals 5y plus 8. And then we solve for y. Well, we subtract 8 from both sides. And then divide by 5. Okay, so we get x minus 8 over 5. That's equal to y. But in fact, that is it's y, but that's the inverse function. And you can check that this is true. If you plug this back in here, you multiply by 5, you get x minus 8, and then you compute x minus 8 plus 8, that's x. And then you can plug this in back in here, and you'll see that you simplify, you get x as well. So that's the inverse function of that. Incidentally, you'll see that this becomes 1/5 x minus 8/5. This is a line as well, which is what we kind of expected, or this is a linear function, since the graph, the graph of this is a line, so the graph of this should be a line as well. All right, to find the inverse of 1 over x minus 2, you know it's not necessarily going to be x minus 2, so let's see if we can do this. We write x equals 1 over y minus 2. And then we flip both, we take the reciprocal of both sides. So we get 1 over x equals y minus 2. And then we add 2 to both sides. And we get y equals 2 plus 1 over x. And so f inverse of x is going to be 1 over x plus 2. Okay. And incidentally, when you look at this, you'll see that this has a vertical asymptote at x equals 2 and a horizontal asymptote at y equals 0. Here we have a vertical asymptote at x equals 0 and a horizontal asymptote at y equals 2. And that's no accident here. When the function is a rational function and you compute its inverse, the vertical asymptotes and the horizontal asymptotes are basically interchanged. Because again, the roles of x and y are switched. Let's look at example 8. 2x over x minus 1. Okay, so this is x. You write x equals 2y over y minus 1. All right. Probably the best way to do this is clear out the denominator. So we'll have x times y minus 1 equals 2y. And let's try to multiply this out, because we want to get multiply this out and then put all the y terms on one side and then divide by something. So then this becomes xy minus x equals 2y. And we'll subtract xy from both sides. So we get minus x is equal to 2y minus xy. And now, because we have all the y terms on one side, we can factor out a y. And we get y times 2 minus x. And then we divide both sides by 2 minus x. So we get minus x over 2 minus x equals y. So f inverse of x is equal to minus x over 2 minus x. Okay. Once again, you'll see that this has a horizontal asymptote at y equals 2. This has a vertical asymptote at x equals 2. It's no accident. And by incidentally, you could also, if you did this differently, you could simplify this, and this becomes x over x minus 2. Just multiply and divide by -1. Okay. Let's say number 9. We want to find the inverse of 2x cubed minus 1. So we write x equals 2y cubed minus 1. Solve for y. Okay, add 1 to both sides. Divide by 2. So we get y cubed is x plus 1 over 2. And then we can take the cube root of anything. So I'll take the cube root of both sides. So y is going to be the cube root of x plus 1 over 2. Okay, so f inverse of x is the cube root of x plus 1 over 2. Okay. All right, and again, the best way to do this is just to get lots and lots of practice.